As the amount of data you're working with increases, it becomes harder to eyeball it and identify patterns in the data or relationships between the variables. This is where data visualization comes in. A picture is worth 1,000 words and definitely worth 1,000 numbers. A chart, a map, or a scatter plot can show you things that you might potentially miss. We use data visualization both as a tool for exploratory analysis to uncover what the data reveal, and as a tool for building a narrative, a story that you can share with an audience and help them to see what you see. When you start to work with your data, it's important to understand the story you're trying to tell and the relationships you are looking to show. Knowing this information will help you select the proper visualization to best deliver your message. When analyzing data, search for patterns or interesting insights that can be a good starting place for finding your story. A simple scatter plot, like the ones you see here, can be very revealing. By plotting a variable such as sales over time, you can see the trend in sales. For example, the first scatter plot shows that ice cream sales are falling over time. By plotting two variables that are likely to be related, such as ice cream sales and temperature, you can see the correlation between them. For example, by separating sales on high temperature days from sales on low temperature days, as in the second plot, you can see that sales increase when temperatures are rising and decrease when temperatures are falling. A scatter plot can also show outliers, that is, observations that are extreme in some way. The third plot shows that sales in some regions are unusually low compared to others, and it may be useful to investigate reasons for those outliers. When you are deciding what type of data visualization to use, you need to think about a number of factors that will affect your visualization strategy. First, what types of data do you have? Do you have categorical variables, also known as nominal variables, that is, which categorize observations into groups? Or do you have quantitative variables, which measure something numerically? Second, what relationships or patterns do you want to show? A trend, a comparison between groups, or a correlation between variables? In the next few slides, we will examine these in more detail. Looking first at the type of data, your data may consist of categorical or nominal variables which are used to categorize observations into groups. For example, gender, zip code, type of product sold, etc. Or you may have quantitative variables, that is where something is being measured, such as inches of rainfall, height, weight, etc. Quantitative variables, in turn, may be discrete or continuous. A discrete variable can only have fixed values. For example, the number of employees in the office can only be 1, 2, 3, etc. A continuous variable can have an infinite number of values. For example, the weight of an object can be 5.1 pounds, 5.25 pounds, 5.375 pounds, etc. Some charts, such as bar charts, require there to be at least one categorical variable, which was product type in the earlier example, while others, such as line charts, require a quantitative variable, such as sales in that example. The second factor to consider is what pattern or relationship you want to show. For example, if you want to compare groups, at least one variable has to be categorical, that is, nominal, and you could use a bar chart. If you want to show a trend or time series, the horizontal axis needs to be some unit of time, day, week, month, etc., and the vertical axis needs to be quantitative, for example, sales. A line chart would be effective for this purpose. If you want to show a correlation between two variables, then both variables need to be quantitative, and a scatter plot or line chart could be used. To show a part-to-whole relationship, for example, the percent of customers purchasing different products, you need at least one categorical variable, and a pie chart would be the most effective. Finally, to show the relative magnitude of a quantitative variable for different groups, a bar chart showing the rank order of values would be useful. Let's pause for a moment to discuss how to create charts in Excel, in case you're not sure how to do that. I won't try and explain the process in the video here because you might already know how to do this, and there are many excellent tutorials already out there. Here's one you could try, but feel free to shop around if you want something different. Now that you have an idea about the overall data visualization strategy, let's dig a little deeper into the specifics of each chart type and when you would want to use it. Here's a summary of the main chart types and what they are used for. A bar chart is where bar or column lengths show differences between categories or groups. They are typically used to show change over time or to compare categories. Pie charts are used to show the size of each part, that is, slice, relative to the whole pie. Line charts are typically used with continuous data to show time series, that is, how the data change over time. Scatter plots show relationships between two variables. Are they correlated, and if so, what is the nature of the relationship? Bubble charts are like scatter plots, but where a third variable is added to the plot, reflected in the size of the bubble. A heat map shows comparisons between geographical areas, with color intensity showing the differences between the areas. It's also sometimes used to show areas on a web page or display ad to show which parts attract the most attention. Looking a little closer at bar charts, there are two common types used to compare categories or time periods. The vertical column chart is the default chart type unless the category labels are very long, in which case a horizontal chart is easier to read. Another variation is the stacked bar chart, which allows you to show the contribution or percentage of different parts to the whole. You can also compare multiple groups or time periods with this format. A 100% stacked chart is one where the total height corresponds to 100%, and the total is not important, but the percentage contributions of the part are the key takeaway. Here are some best practices. Use horizontal labels to make them easy to read, or tilt them at an angle if they don't fit. The space between bars should be half the width of each bar. Start the y-axis at 0 so that viewers can accurately interpret the height of the bars. Keep colors consistent across bars. Only use a different color when you want to highlight a particular bar or data point. Order the bars alphabetically or by value. Line charts are used all the time, mainly to show time series data. The variables must be continuous for this to be effective. Best practices for line charts include using a zero baseline is preferred, but if the variations in the data are small, you can truncate the scale to make these changes more visible. Use fewer lines rather than more. Too many lines is confusing. If you need to show more, put them in a separate chart. Use solid lines only because dashed or dotted lines are distracting. Place labels next to the lines so they can be easily interpreted instead of putting them in a legend box. Use the right height so that the plot takes up about 2/3 of the y-axis length. Scatter plots are commonly used to show relationships between two variables. This chart shows the relationship between ad expenditures and sales for various product families. Best practices for scatter plots are start the y-axis at 0. If you need to include more variables in the plot, such as product type or profitability, you can do so by using different colors or bubble sizes. Use trend lines to show the nature of the correlation between the variables. If you want viewers to compare trend lines, don't show more than 2 at a time, as that can make it difficult to interpret. Bubble charts are like scatter plots, but a third variable is added to the plot, reflected in the size of the bubble. For bubble charts, best practices include making sure the labels are visible and can be identified with the corresponding bubble. Size the bubbles based on their area, not diameter. So if bubble 1 has twice the value of bubble 2, it should have twice the area of bubble 2. Avoid using shapes that are not symmetrical around their center. For example, the money bag shape in this diagram. This can lead to errors in interpretation. Heat maps are typically used to compare geographical areas with intensity of color used to show differences. In this example, the darker shades indicate states that have more service contracts. For heat maps, best practices are use a simple map outline and avoid the use of thick lines for the borders. Instead of using different colors to show different values, use a single color with varying shades to show high and low values in the data. Don't use patterns if possible, as they can distract rather than clarify. Use appropriate ranges for the different shades such that there is a roughly even distribution of data between them. In the example, instead of using ranges with 6, 2, and 7 values each, a better approach would be to use ranges with 2 or 3 values in each.